Hi guys! Welcome muli sa ating series of discussion about statics of rigid bodies. In today's discussion, I will present to you some concept on how are we going to solve problems like conditions of equilibrium. Ang napupuna ko kasi guys sa mga experience ko, kalimitan ng mga estudyante kapag binigyan ng problem at walang value ang mga given, doon sila natatakot i-solve ang problem. Kasi unang-una, kapag naging dependent ka sa calculator, malakas ang loob nila. Subalit kapag ang problem na ay normally in the form of symbols, talagang worried na worried. Pero guys, sa pamagitan ng lecture na ito, ay tutulungan ko kayo na tanggalin yung ganyang worry kapag nag-solve tayo ng problems, lalong-lalo na nga kapag ang given ay hindi number kundi symbols. At itong problem na ito ay kinuha ko mula sa libro ni Singer sa kanyang libro na Statics of Rigid Bodies. At ganito yung problem. This problem was taken as part ng problem -3-4.12. And the problem is to find for the force exerted by either ball bearing on the cylinder. When we have two smooth ball bearings, each of weight W and radius R, are placed inside a cylinder that is open at both ends. The assembly rests on a horizontal surface, and if the cylinder is of weight W and radius equal to R, which is less than twice the radius of the ball, we are required to find for the following. Letter A, the force exerted by either ball bearing on the cylinder, the smallest value of W that will prevent the cylinder from tipping over, and the question of could the cylinder be possibly tipped if it were closed at the bottom. So bago natin solvein ang problem guys, medyo i-analyze muna natin ang problem para maunawaan natin mabuti. So ganito yung problem. Meron tayong cylinder dito na ang kanyang diameter is twice R. Yung R represents the radius of the cylinder. Inside the cylinder, is placed or are placed two ball bearings whose radius is equal to R. So we should expect that the radius of the cylinder must be less than twice the radius of the ball bearing. Otherwise, kapag hindi nangyari yan, mahuhulog lamang itong cylinder nito, and then the question letter A will not be answered anymore. Kaya ang condition is that the radius here must be less than twice the radius of the ball bearing. And we are required here to find what is the force exerted by this ball bearing upon the cylinder. At kung sakali daw na itong ilalim na ito ng cylinder ay may takip din, may chance ba na mag-tip over siya? Pag sinabi natin tip over, maaaring dito siya magtitip. Kumbaga, iikot itong cylinder in that direction. Matutumba siya dahil sa bigat ng ball na nakalagay sa loob ng cylinder. Kaya nga ipinapahanap sa atin, what is the smallest value of the weight of the cylinder that will prevent it from tipping over? Diba? So there is actually an answer in the book. I have just not included here. Para I will be hindi worried to check to solve this problem. So how are we going to solve for this problem? So to solve for this problem, let us try to consider isolating the two ball bearings as the free body diagram. Yung mismong dalawang ball bearing na nga naman ang ating i-isolate muna pansamantala. Ang purpose natin yan ay para makuha natin ang dimensions ng ilang part ng problem. So if we will be isolating it, kunin natin yung part na yan, sabihin natin itong nasa ibabaw ay tawagin nating cylinder A, nasa ilalim ay tawagin nating cylinder B, ba? And then the radius of the cylinder are given. They are given as R. Now let us try to imagine that the cylinder has a radius or diameter equal to 2R. Now if the radius of the ball bearings are equal to R, sa makatwid itong dalawa na ito, R din yun. At mula dyan, makukuha natin itong horizontal distance between A and B. And this becomes equal to the difference between 2R and the radius of the ball bearing. Diba? Ngayon, puntahan natin, try to imagine natin that we try to draw a line to connect this A and B by a line. Okay, connect natin yan. So, because we are given the radius of the ball bearing, therefore the distance between A and B will be equal to 2R. Ngayon, subukan natin na mag-drawing ng horizontal line dito sa B until it crosses this part. So, this is how, okay? And let us call this point as point C. Okay? Sa mga tuwid, itong BC na ito ay makukuha natin because that BC will be equal to 2R times 2R. And then, okay, this triangle ABC, okay, we can say that that triangle ABC is a right triangle. And therefore, we can solve for AC by Pythagorean Theorem. So, we can solve for side AC in the triangle ABC using the Pythagorean Theorem. Ano ba yung Pythagorean Theorem? Yung Pythagorean Theorem sinasabi, the square of the hypotenuse is equal to the sum of the square of the sides. So that if we are looking for the side AC, which is one of the two sides in the right triangle, therefore the square of AC will be equal to the square of AB representing the hypotenuse minus the square of BC, which is the other side of the right triangle. Now, if we will be substituting the value of AB, diba? Sa makatwid, masolve natin, AC square will be equal to AB square, which is equal to 2R. If we will be substituting 2R, then that is equal to 2R square. And BC having that value equal to 2R minus 2R, therefore that is equal to minus 2R minus 2R square. Diba? So that this can be expanded. Pwede natin to expand, and that becomes 4R square. And we can factor out 2 here. We can factor out 2 here, so that becomes 2 times R minus R quantity square. And if this will be expanded further, therefore this term will become equal to 4 times R square minus 2RR plus small r square. And if we will be distributing 4, and then we remove the parentheses, and then we rearrange, then that becomes equal to, we factor out 4, then that becomes 4 times the quantity small letter r square plus r square, minus r square plus 2rr minus r square. And you will notice that the small r square will cancel. So that what will remain is the value of AC when this term will be extracted its root. Then this becomes, what is the square root of 4? That is equal to 2 times the square root of, I simply arrange this one, so that this becomes 2rr minus r squared. So this value of AC is now expressed in terms of the dimensions of the radius r and the radius of the cylinder and the radius of the ball bearing. And that is the distance AC. Now, to consider now, to solve for the value of the force acting at the cylinder caused by the ball bearing at this point, then what we do is to try to isolate natin yung ball bearing A as FBD. Ihiwalay natin itong ball bearing na yan at dalhin natin dito sa side na ito. Ba? So, tingnan natin this point is this ball bearing has a weight now given as small w. Yan, may small w dyan, di ba? Now at this point, since this is connected or attached to this wall, therefore at this point, natatawagin nating point D, will be subjected to a horizontal force F1. And we would expect that F1 shall be directed towards the center of the ball bearing. Similarly, at this point, which is this point, so tingnan natin yung point na yan, so we would expect therefore that the lower ball bearing will be exerting a force towards the upper ball bearing at this point and directed towards the center. Ito yung center niya. So there will be now a force exerted. Okay, tawagin ko ito because I do not know that magnitude. So I'll just be calling it as FAB. The force exerted upon A of the ball bearing B. And we would expect that this ball bearing or this force exerted by the ball bearing B upon A is inclined at an angle theta with respect to the horizontal. Okay, angle theta na yan, na kung saan yung theta na yan will be taken from here. This value also, ano? Okay. Now, because you have here an equilibrium, okay, condition of three forces and they are concurrent, so we can solve here, no? This problem or these forces, unrelated forces, using the force triangle method. So if we will be using the force triangle method, paano ba nga uli yung ginagawa yung force triangle method? So we can draw force one by one. So let us try to start with drawing the weight somewhere here. That's the weight. Then we draw the F sub 1, which shall be drawn at the tip of W. And then at the tip of F sub 1, we draw the FAB. FAB is inclined at a certain angle theta, therefore this angle shall be equal to theta. And because W and F are perpendicular, therefore the resulting triangle shall be a right triangle. So that this upper part, itong angle na ito ng right triangle, will be equal to a complementary angle with this angle. And therefore that is equal to 90 minus theta. And because we now have a force triangle, so we can now apply the sine law. Sine law, a function of a triangle, using a sine law. Actually, sine law can be done, So you have now W is to sine of the opposite angle, which is sine of theta, shall be equal to F sub 1 is to sine of the opposite angle, which is sine of 90 minus theta. And because we are looking for F sub 1 here, therefore F sub 1 can be solved as the product of W multiplied by sine of 90 minus theta divided by sine of theta. That is W times sine of 90 minus theta divided by sine of theta. But again, sabi ko nga, ano ba itong theta na ito? Itong theta na ito, itong angle na ito, na kung saan this angle is also equal to this angle. And therefore, if that would be the same as this angle, we can now get the function of theta as well as the 90 minus theta being this angle, using the sides of this triangle. So that yung sine of 90 minus theta being the opposite side to the adjacent side of this angle. Ito yung angle na tinutukoy natin. Ang kanyang opposite side is 2r minus 2r, while the hypotenuse is 2r, which is actually AB. So this could be rewritten as the product of W times BC being the opposite side of this angle divided by AB being the hypotenuse of that angle. While sine of theta shall be the ratio of the opposite of this angle. Ito naman yung angle na tinutukoy natin, and the opposite is AC to the hypotenuse AB. That is AC to the hypotenuse AB. And you will notice here that both AB can cancel each other. That would be simplified into the product of WBC divided by AC. But we already have computed for BC and AC. So BC is this angle by this side, that is equal to 2r, 2 times the quantity r minus r, while AC is already computed to be this value, and that is this value, diba? And that is equal to 2 times the square root of 2rr minus r squared. You will notice here that 2 will cancel, diba? So that this can be simplified to be W times the capital R, or the radius of the cylinder, minus the radius of the ball bearing divided by the square root of twice the product of the radius of the cylinder and the ball bearing minus the square of the radius of the cylinder. And that gives us the force exerted by the ball bearing upon the cylinder, as this is also the force exerted by the cylinder upon the ball bearing. And this is our answer now. So to solve for the second question, Okay, whether to find out what is the minimum weight that will prevent the cylinder from tipping, diba? So let us now try to continue, and this time we consider isolating the cylinder as free body diagram. Let us now try to consider this cylinder. Kunin natin yung cylinder na yan at i-isolate natin dito, diba? So in this cylinder, meron tayo dito itong point na ito representing this point. Tawagin ko siyang point D, diba? So this is now subjected to a force F sub 1, which is this value. Okay, which is this value already taken, diba? As well as this point, this cylinder ball bearing is attached to this cylinder at this point. So meron tayo ditong point sa kabila at tawagin ko siyang point E. And this is also subjected to a force equal to F sub 1. Okay, because when we sum up forces horizontally, then this force shall be equal to that force. So aside from these two forces, meron tayong weight ng cylinder, and the weight of the cylinder will be acting at its geometric center. Tawagin natin siyang capital W. And the moment are the distance of this W. Okay, from this point where it will tip, therefore it will be equal to, okay, yung point o na yun, yung kanyang tipping axis, ano? It will be equal to the radius of the cylinder. Now it is important that we also define the distance of this D as well as A from O. So let us define that, and let us now try to define, no? So itong distance na ito actually is our AC, itong distance na ito, and that is already taken to be 2 times the square root of the product of 2 times RR minus R squared. Whereas this distance is the distance of A from the bottom, and that represents the radius of the ball bearing. Yun. Diba? Now, ano ngayon meron tayo dito sa cylinder? You will notice that the cylinder is now acted by 3 forces. One force is F1 acting at this point, ba? Another force is F1 acting at that point, and the third force is W acting at the center, which is the unknown. Ba? So how are we going to solve for that W? Ang sabi niyan, it should prevent the cylinder from tipping over. So paano ba yon? So to prevent the cylinder from tipping over about O, about this point, therefore, the tipping moment, yung moment na magkakos yung tip, and that is actually the force, the moment due to this F1 acting about D, should be equal to the resisting moment. And the resisting moment are those moments that will be produced by the weight and the moment due to this F sub 1 in the opposite direction acting at point E in the other side of the cylinder. So the moment is supposed to be by this F sub 1, okay, shall be equal to the moment that is produced by this W and the moment that is produced by F sub 1 to prevent that from tipping. So mga katwid, how are we going to solve for that? So the tipping moment about O is caused by the clockwise moment by this one, while the resisting moment is the moment caused by all the counterclockwise, which is due to W and F sub 1. However, you will notice that there are pair of F sub 1 here. F sub 1 acting to the right and F sub 1 acting to the left. If we are going to recall the definition of a couple, then this actually constitutes a couple whose magnitude is equal to F sub 1 multiplied by this moment arm. And the direction of the couple is clockwise. And we know that a clockwise moment or a couple is actually a tipping moment. So yun yung magkakos ng tipping moment, tipping movement or action of the cylinder. So it should be caused by the couple produced by F sub 1. And the counteracting or resisting moment will be the moment that will be produced by W from that. And so how are we going to make an equation? The equation must be, the resisting moment must be equal to the tipping moment. And what is the resisting moment? That is the product of W multiplied by the moment arm equal to R. While the tipping moment is just equal to the product of F sub 1 multiplied by this distance, or simply the couple produced, because that is producing a clockwise moment, and that is equal to this W times R minus R times the square root of 2RR minus R. And what is this value? Actually, ito yung ating F sub 1. At ano yung kanyang moment arm? Ang moment arm niya ito. Okay, and moment arm niya is 2 times square root of 2R times the quantity r minus r squared. And you will notice that this square root and that would be cancelled. Ano na lang matitira? The product of, okay, yan, we will be simplifying. So what will happen? It will be equal to twice the product of W times the quantity R minus R divided by R. So yun ang sinasabi nating minimum value of the weight that will prevent the cylinder from tipping. Diba? Now, yung third question. Ano ba yung third question? Is it possible that the cylinder would tip over kung sakali daw may takip sa ilalim? Diba? So how are we going to answer that question? Let us now continue. Now let us now try to isolate the cylinder. This time as FBD, but the cylinder is closed at the bottom. So again, ipinakita ko yung cylinder dito, kaya lang dito is closed at the bottom. So ano ngayon ang implication kapag closed at the bottom siya? Sa mga tuwid, itong bottom ball bearing would transmit a load at this point, which is at that point, meron siya ngayon matatransmit na load, di ba? Ano yung matatransmit na load niya? Yung sum ng weights itong dalawa. If the cylinder would have a weight equal to small w, therefore, this bottom cylinder will be transmitting a load here equal to twice the weight of the ball bearing, which is equal to 2 times W. Diba? So, ganoon din ang scenario, Scenario. Kung titignan natin, at ang kanyang distance, by the way, distance nitong 2W will be equal to the distance between this one, and that is equal to 2R, representing the diameter of the cylinder, minus R, representing the distance from this point up to that point of the ball bearing. Diba? So, kung titinan ulit natin dyan, meron ulit tayong tatlong forces acting upon the cylinder. Meron tayong F1 acting at D, F1 acting at T, and the third force is the force 2W acting at H in this case. And this 2W is the one resisting the moment. Diba? The one resisting the moment. Kaya nga sabi dyan, the cylinder will not tip about if the moment caused by 2W at H is greater than the tipping moment due to the couple produced by F sub 1. Diba? Kaya kung kukumpitin natin, yung resisting moment, ano yun? It is 2W representing the magnitude of this one. And this 2R minus R is the moment arm of 2W from O. So that when we simplify, that becomes 4W R minus 2R, diba? Okay, yun yung kanyang resisting moment. And what about the tipping moment? Kanina naipakita natin yung tipping moment, diba? That is equal to W times R minus R times the square root of 2RR minus R square multiplied by the moment arm or the distance between the F's, and that is 2R. Again, these two will cancel. At ang matitira lamang dito ay turning moment, tipping moment is equal to 2W times R minus R. Diba? Or if we will be distributing 2W, then that becomes 2WR minus 2WR. Now let us now try to compare. This is the resisting moment, and this is the tipping moment. You will notice that the tipping moment have the same value as well as the resisting moment, 2WR. Which means they are the same in terms of the moment produced by the radius. However, in terms of this part, the first term is greater than this term. Hence, we would expect that the moment, the resisting moment is greater than the tipping moment. Sa mga tuwid, ano ngayon mangyayari? The cylinder will not tip when the cylinder is closed at the bottom. There is no way, no chances that this would tip, even if we consider that the cylinder is negligible in terms of the weight. Okay? So, guys, yan ang sinasabi natin na konsepto na magandang dapat ay naunawaan natin para hindi tayo nangangamba na kapag ang ibinigay sa ating problem ay kalimitang in terms of symbol. At makatutulong yan kapag nasanay tayo sa konsepto, katapos na develop pa natin yung ating skills sa paggamit ng calculator, garantisado. Any kind of problem you can always solve the problem. So guys, sana ay nasundan ninyo yung ating discussion at sana ay lagi ninyo akong subaybayan sa ating ginagawang lecture about statics of rigid bodies by subscribing to this channel and sharing it to your friends so that your friends would also be notified of this lecture. Once again, thank you very much for watching.